Okay, so today we're doing 8.2, multiplying and factoring. I'm going to rewrite this problem a little bit bigger so it's easier to work with for me. And they can see it in person a little bit better as well. So I walked down to counseling yesterday and was talking to counselors about a couple students I have I was concerned about, and their topic of conversation was, when do you think we're going to shut down, as in not be here in person anymore? Nobody knows the answer to that question, right? We have no idea. But I just know that anytime there's any kind of holiday, we see a spike in COVID numbers. So because of Halloween, it was 6 days ago, we'll probably see another spike. I would personally bet a decent amount of money that we would shut down about a week from now, because I don't know if you've been paying attention to COVID numbers in Colorado. They used to be like 300 or 400 per day, and for about the last 5-6 days, they've been over 2,000. Yesterday it was like 2,400. 2 days before that, it was almost 3,000. It was like 2,700 or something like that. So that's like times 6 or 7 higher. And that's exponential right there. And if you look at a COVID curve, it is actually exponential. But if we have a spike on top of our current numbers, I can't imagine we won't get shut down, but we'll see. So when you're in public, just mask up, right? Just hang out with the people. Like most of your parents have like people you can hang out with. Like my stepdaughter is a senior at Ralston Valley. She hangs out with her boyfriend and like 2 or 3 other friends. That's it, right? So try to do that kind of stuff, because that's how we keep those numbers down and we can stay in person. Because I enjoy being able to see you actually live in 3D as opposed to on the screen, especially if your tile's off, because that just makes me mad, to be perfectly honest. So we've got this problem here. We're going to multiply first. Does anyone remember? No, not a single person remembered, which was kind of disappointing last period. Does anyone remember the strategy I gave you for doing this kind of problem? Dawson?
Add the 1.
Yes, we are going to add the 1. I heard a little bling. I think we... Oh, there.
Distributive?
Yep, but we are going to distribute. That's right, Anna. But it's like multiply something and add something else.
Multiply coefficients and add exponents?
Yes. Oh, Jackson even used a coefficient term. I like it. So I make it easier because some people don't know what the word coefficient means, even though I defined it for you yesterday. But what I like to say is multiply numbers, add exponents. Thank you, Jackson, for restoring my faith in high school students. Multiply numbers and add exponents. So it's a really good idea to make flashcards with this stuff. You got to remember this stuff. So the fact that I taught it to you like a week ago, and I had 1 person out of the 50 freshmen that I have remember, and there are probably more than that, right? Some people are just too chicken to answer. Make a flashcard out of that, because you'll be doing that kind of stuff from now until you're done taking math classes, which will be sometime in college for many of you. Unless you're like me and you get a life sentence of math. Being a math teacher, but I like it, so. Okay, let's multiply. So I'm going to put the 1 in front of that x cubed, because we have to multiply the number, and sometimes students get confused if we don't do that. So we're going to multiply that one first. So negative, and I like to do it piece by piece. The numbers first, negative, positive, and then add the exponent. So negative 1 times 9, negative 9. And then I have 3x's here and 4x's here, so 3 plus 4 is 7. So negative 9x to the 7th power. Then we'll do the next one. So negative times a negative is a positive. So negative 1 times 2 is positive 2. 3 plus 3 is 6, x to the 6th. Next one, we have negative 1 times 7. So negative times a positive is a negative. So I had a student ask last period, I was thankful that they asked this, a lot of times you guys will write it like plus minus, because you're multiplying a negative times a positive. Every single time I'll take points off for that, because what's a positive times a negative? A negative. So don't write plus minus. That's your warning for that. So negative times a positive is a negative, so x cubed, or negative 1 times 7 is negative 7, and there's no other x with the 7, so you just write x cubed. So we're going to do one more like this in the next slide. This is where I lose people. Most of you guys will understand what I just did, but in the next slide what we're doing is we're going from this kind of problem and then we're factoring. So if we go in the opposite direction, that's called factoring. What we just did is just multiplying, right? Or using distributive property. So that's what normally confuses people, is go in the opposite direction. We'll do like 5 or 6 problems with it, so if you don't get the first couple, you'll get it eventually, because it can be tricky for sure. Alright, I'm going to rewrite this one a little bit bigger too, so 5n, and then we have 3n cubed minus n squared plus 8. So I always like to add the little ones in, and you guys know me by now. Do I need to add the little ones in? Like, am I going to get it wrong if I don't? I'm going to get it right? I'm a freaking math teacher. Of course I'm going to get it right. Sometimes I'll screw up and make stupid mistakes, but the reason I always put the little ones is because I want you to do it, because you get more problems correctly if you do. So I'm going to put a little 1 there, and I'm also going to squeeze one in between the negative and the n squared. And then you're going to make way less mistakes, because if I'm adding exponents and I see the 1 here, right, I'm going to add the 1 in the 3 to get 4. If I don't have the 1 there, I'm probably going to say it's n cubed and get the wrong answer. And then my favorite thing to do once I get to know you is I'll take a half point off and I write ha-ha, just to rub it in a little bit, right? Rub some salt in that wound, because that's fun. And that's ironically what makes students like me, because I'll make little jokes like that, and you're like, you son of a... But you kind of laugh at the same time, you know? Okay, so 5 times 3, 15. 1n plus 3n, so there's 4 of them. 5n times negative. So 5 times negative 1 is negative 5. We'll do a piece at a time, like I said. And then we have 1 at the beginning and 2 here, so 3 n's in the middle. Now we do 5 times 8, which is 40. And then there's no n with the 8, so we just write it down. You can put the 1, you don't have to in your answer, I don't care. But I just find it super helpful if you put the 1s here and here. Okay, so do that. So this is kind of the easy part when we go the opposite direction. So we go from this answer to that. That's where it gets challenging. So you'll get it eventually. So this says list the prime factors of each term. I'm not going to do that for the first example. We'll do like 2 or 3 of these, and then I'll show you the prime factorization, and you'll never want to do it again, okay? Because it's kind of a nightmare. But it may help 1 or 2 of you understand how to do these problems, so that's why I will do it. But I'll show you the way I do it. I think it's better. So we have 5, I'm just writing it bigger, 5x cubed plus 25x squared plus 45x. So how the heck do you factor? That's what we're doing. We're trying to find the greatest common factor. But we're going to go through and do the whole process where we have something factored in front like we did here, and then once we divide out that negative 1x cubed, we end up with both of these, the thing in front of the parenthesis and the parenthesis, okay, and that's what tends to confuse people. So we need a little strategy, like helpful hint for this thing. So what we're going to do is we're going to think about the biggest number you can divide out of each term. So you're looking for the biggest number. I don't know why I wrote 2 G's. I'm having a psychotic moment. I'm telling you, the heat gets to me eventually.
It's so
I'm just
hot,
like,
yeah.
I know, it's ridiculous. 77.1 now, it went up a half degree since we added like 6 people, plus me. So biggest number is what we're looking for. So I'm just going to start there. I'm going to write more to this helpful hint, but we're just going to start kind of one thing at a time. So we're looking for the biggest number. So what is the biggest number? You can show me at home too, that you can divide out of each of these 3 terms. That's right, Elise. Good job, Rutledge. Rutledge gave me one of these. Always looks good in the camera. So we're going to divide out a 5 out of each of the 3 terms. So if you look at the book, they do not do it this way. I just find that students have the most success doing it this way. So we're looking for the biggest number. I always struggle with how to talk about the exponents. It's usually, I'll say, the biggest exponent you can take out, but then people want to divide out an x cubed. Can't divide an x cubed out of an x. So the biggest number and the smallest exponent, I think, is the best way to say it. I said it opposite last period, and it just confused the hell out of people. So biggest number, smallest exponent. So what's the smallest exponent here? Smallest variable? Maybe I say smallest variable. What makes it easier to understand, variable or exponent?
Isn't variables or x?
Yeah.
So I think both are fine. I don't know.
So either exponent or variable. If variable makes more sense to you, write that. If exponent makes more sense to you, like you have to have the exponent, you have to have the variable to have an exponent. I don't know. I haven't ever figured out the best way to say that. So if any of you guys think of a good way to say that, please tell me. Because I love when a kid gives me a strategy I haven't thought of. It's cool. Like I had this German foreign exchange student show me a trick on the graphing calculator, which I've used ever since. It was really cool. He's like, why don't you do it like this, Evans? And I was like, what? That's amazing. Well, I'll actually show you how to do that later on in this chapter. If you have a graphing calculator, you can do it. If you don't, then you can't.
Oh, I forgot my own.
Oh. So we have 5x. That's what, right? If we're thinking about doing that process in reverse, the 5x is like this negative 1x cubed thing that goes in front of the parenthesis. So remember, we're doing the opposite direction here of what we did on the first slide. So the 5x goes in front of the parenthesis. Then what you do is divide the first fraction, okay? But, you know me, I'm going to add all these little ones on the x's so you guys don't screw it up, okay? So 5 divided by 5 is what? Show me at home. Show me in person. 1. Do you have to write the 1?
Nope.
No. I'm going to write the 1. Would I write the 1 if I were doing this problem? Hell no. But I'm going to write it
Wait,
because
what?
it'll help.
What do you like the 5?
Just like going in reverse, right? So why do I write the negative 1x cubed?
Oh.
Because when I multiply it back in, I end up with the negative 9x to the 7th. Okay? So those are good questions to like put the brakes on to help kids understand. So please ask them. So now we subtract the exponents, right? So when you're dividing numbers and exponents, you divide the numbers, subtract the exponents. So if you need to remember that strategy, write that down too. Divide the numbers, subtract the exponents. I'm going to write it because I want you to write it too. So divide numbers. Nice dive. See, I'm losing it. Divide numbers. And subtract exponents. So subtract exponents, 3 minus 1 is 2. So 1x squared, you don't have to write the 1. I won't take points off for that. If you write plus minus, hell yeah, I'll take points off and write haha. 25 divided by 5? 5. 2x's divided by 1x, just have 1x left over. 45 divided by 5 is 9, so plus 9. X divided by x is 1, so you don't write anything, right?
Wait, for exponents to subtract.
Right, what's 1 minus 1?
You said divide. 4.
Divide numbers. Oh, did I say the wrong thing?
Yeah, you said
Okay.
divide.
Okay,
I
see?
think we got it.
I'm hanging on by a thread, what can I say? Alright, we good? So give me 6 to 5 on your level of understanding right now after that first one.
Oh.
Austin's giving me a 3.5.
I did a thumbs up.
That was
for
pretty
that
good.
one, so.
3.5, already gave me 3.5. Okay, so we'll keep going, right? We're going to do like 4 of these, so you'll get it by the end, for sure. Alright, take a minute, write this one down. 3x to the 4th minus 9x squared minus 12x. So what is the biggest number I can divide out of 3, 9, and 12? 3? Is that what you said? 3? You're right. 3. Let's write it in purple. How about if each of those terms was negative? Yeah, so just think about that, right? Because they'll mess with your head with homework problems. So if they're all negative, make sure you divide the negative out as well. And then the smallest variable or exponent is, yeah, Rutledge got it, x to the first power. So it's just 3x. You can divide out. That 3x goes in front of the parenthesis. Put that one right in black. Organize use of color. So, I'm going to put all the little ones on there. You too should put the little ones. I swear to God, you're going to miss it if you don't. So 3 divided by 3 is, answer at home too. Good job, Cole. Sasha, Elise, good job. Anastasia, doing it as well. So 3 divided by 3 is 1. 4 minus 1 is 3. So x cubed. Negative 9 divided by 3 is negative 3. 2x's minus 1x, just 1x left. Negative 12 divided by 3 is negative 4. X divided by x, 1. Right? Because technically if we subtract this, right, x to the first over x to the first, we get x to the 0 power, which equals 1, right? So that's why that makes sense, subtracting the exponents. So there we go. So there, notice that this says, what is the greatest common factor? So the actual answer to that question is 3x. But I just want you guys to factor them as well, because it's just better if you do. It'll help you understand this stuff better if you do the whole thing. Okay, so now this says factor out a monomial. That's what we've been doing. The one highlighted here is a monomial. Okay, so we're going to do the whole process again, basically. So 4x to the 5th minus 24x cubed plus 8x. So after we factor this one normal style, I'm going to show you that prime factorization thing that you'll never want to do again. But it's good to have that knowledge, because if you get stuck, if you can't figure out how to factor it, you can always rely on the prime factorization. So what's the biggest number I can divide out? You? Good at home? Good, I like that, Rutledge. Good, Johnny, 4. So we can divide out a 4, and a 4, and another 4. And smallest variable is, show me at home. I was hoping you'd do this. Right, x, come on, people. So 4x, good. Just, I want you to think about how easy this is in compared to when I do the prime factorization. Because you're going to be like, oh my God, I'll never do that again in my life. But you may have to because you can't figure it out. So we're going to take that 4x, write it in front of the parentheses. You know me, I'm going to add all the little ones. That took like 1.5 seconds. So don't be lazy, just add the little ones so you don't screw up, okay? And divide the first, what do I have left? X to the...
Fourth.
Yeah, I knew you correct yourself. 4 divided by 4 is 1, which is what you're showing me, right? So you can write the 1, you don't have to. But if it's going to make you get it right, write the stinking 1, you know? Negative 24 divided by 4 is what, Dawson?
5.
Try again.
Oh.
Negative. You're going to get it.
Pass. I'm not.
I just freaked him out because he thought he had the right answer and then it was wrong. And he's like, oh my God, I don't know anymore. What's my name? I don't know. Austin?
6.
Yeah.
Okay.
You knew that, right?
Yeah.
That was just the stress of the moment. You're like, oh my God.
5.
Yeah, you're good. You're good. So negative 6, 3 minus 1 is 2, so negative 6x squared. Right, those are the tough moments when you get asked a question and you're positive you have it right, and then it's wrong, and you're like, oh God. 8 divided by 4 is, show me down, punks. Very good. You respond to evil. X divided by x is, goes away, it's 1, nothing left. There you go. Looks good. I'm going to copy this to the next page, and I'm going to show you the prime factorization that you'll never want to do again in your whole life. Because it'll be fun. That's going to annoy me. I'm going to rewrite it. So 4x to the 5th minus 24 x cubed plus 8x. Okay, prime factorization. The question I should ask you is, what is a prime number?
A number that can't be multiplied by another number to get it, other than 1.
Other than 1. Good. That was the key add you did right at the end there. Right? It's only 1 times the number. Those are the only 2 things you can multiply to get it. So 1 is kind of its own weird little number. We don't consider a prime because 1 times 1, the 1 repeats. It's weird. Math gets weird, especially as you get into higher levels of math. It's like mind-blowing, weird stuff happens. But that's kind of where it gets cool as well, if you like math, that is. So, what is, other than 1, what's the first prime number? Smaller. Charlotte said 3. 2 is a prime number because 1 times 2 is 2. There's no other 2 numbers you can multiply together to get 2. That's what makes a prime. What's the next prime number? 3. Next one?
7.
No.
Smaller. 5. 7's the one after that. What's the next one after 7?
11.
Ooh, that was fast. Next. Next, nope, there's one before 17. 13, 17, next one?
19.
19, good. You guys are good. What's after 19? 23.
No, yeah.
Right, so this is like math teacher trick, right? Being able to list them super fast, right? 2, 3, 5, 7, 11, 13, 17, 19, 23, 27, no, 27 is not it, 29 is the next one after that. What's the next one after 29?
31.
31, nice. Next one after 31? Oh, now your brain's starting to smoke, right? Smoke coming out of your ears. Next one, what did we say was the last one we said?
31.
31.
43, one of them, just in general.
43 is the prime number. So after 31, 32 no, 33 no, 34 no, 35 no, 36 no, 37. Next one. 38, no, 39. So sometimes once you get in higher numbers, it's better to do it like that, like list them all off and think about it. So prime factorization. So what two prime numbers multiply together to get 4? 2 and 2. So we make like a little factor tree kind of deal. So 2 times 2 is 4. So that's the prime factorization because those are the numbers that multiply together to get 4. Okay? Now, we're not going to deal with the x's just yet. I'll kind of write it below because if I write a big string of things, it just gets confusing. So when you do this prime factorization, it's always good to start with 2 as long as it divides into the number. If not, it's probably a 3. It won't mess with your head too much in Algebra 1. Algebra 2, all bets are off. So 2 times what is 24?
24?
No, 2 times what is 24?
Oh, 12.
12. 2 times what is 12? 6. 2 times what is 6?
3.
Right, 2 times 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. Yeah, you probably did it in elementary. So we'll tie it all together so you can see how you use this prime factorization to come up with the greatest common factor. And then you'll probably get mad because you'll never want to do it again. I'm going to erase all the little highlights because I'm going to use the highlights later. So 8. 2 times what is 8?
4.
Good. 2 times what is 4? Okay. So if we want to figure out what the greatest common factor is, we look at the prime factors that are in common between all 3 terms. So I'll say that again because it's a mouthful, right? So we look at the prime factors in common between all 3 terms. So if we take a 2 from this one, we've got to take a 2 from that one, and the last term. So we still have another 2 left, and we still have 2's on the last 2 terms, so we can grab another 2 as well. So all of that work to know that you can divide a 4 out. Doesn't that make you mad? Like, it makes me a little mad. It makes me mad and I already did it. But that's the second time I did it, so I'm justified to do that. Okay, so now we got to figure out the x's, which is a lot easier. We can take one x out.
Wait, why do we need to do that, though?
You don't have to.
Oh.
It's just how the book teaches you how to do it.
Oh.
And I came up with this way, which is a hell of a lot easier, don't you think?
Yeah.
Yeah. Okay. Most teachers will show the 4x here, and then they don't show the 4x's here, here, and here. The reason I like to show them is because it's easier to see what you're dividing out for each of the 3, and you're less likely to screw it up. Now with the x's, it's even stupider than the prime factorization, to be honest, because I've got 5 x's here. Sort of like to call it the problem. We have 3 x's over here. We only have 1 here. So if I grab 1x from the first one, I can grab 1 from the second, 1 from the third, and that's all I can do. So that was like 10 minutes to come up with 4x, right? So if you feel like a little murder vibe coming on right now, I understand. It's okay. Don't kill anyone, but you know what I'm saying. So now we talked about prime factorization, and we have something other than 2. So what's the biggest number that divides out of those 3? Oh, 3. Right? So we can take a 3 out. And then what's the least number of x's we can take out of all 3? 2 of them. Okay? So it's not always x to the first power. In this case, it's x squared. We can divide out a 3x squared out of each of the 3 terms. Any questions at all? You guys good?
Wait, and then when you write the equation, would you, like the first number would be 3x squared?
Exactly.
Okay.
So that's why I always like to circle it and draw that big arrow, because then it just solidifies it in your brain. So when I divide that first fraction, what do I get?
3.
3x to what power?
4.
Good. 3x to the 4th power. Because 9 divided by 3 is 3. 6x's divided by 2x's, you have 4 left. Or 6 minus 2 is 4 is the easier way to say that. What's next? Wait, question? So 9 divided by 3 is 3, right?
Oh, never mind.
Okay, good. And then 6 minus 2 is 4. Okay? So what's the middle term? What do I get? 5x to the second, excellent. And then the last one?
4x to the 4th, just 4.
Just 4. Good. I like how you corrected yourself in the moment, right? It was good. So it would be 4x to the 0, x to the 0 is 1, so it's just 4. Good stuff. Any questions at home? We're just rocking through these things. I guarantee some of you have questions. You're just too chicken to ask. Just know that if your camera is consistently off, I will never write you a letter of recommendation for college. Not a chance. Just saying. All right, do you have a question, or did you just forget to take your hand thing down? It suddenly disappears. He says nothing. Okay, so we're done there. Blank screen. Woohoo! All right. Before we do this, what I did last period, because sometimes they'll throw homework problems at you, like the examples don't match up at all, and I can see people at home. Yay! You can't see the Ari's picture though, unfortunately, Maddie. Like, never see you again. What's the one I wanted to do? Or how about you guys? Which one looks hard on here? Which one looks like it'll mess you up?
26.
26?
No, not all wrong.
It's not that bad, honestly, though, you know. We have 26 because there's no number in front of the g to the 4th. We just take out that single g. That's all. Which one?
They're all coming out. Yeah, they all look the same.
So the one I did last period,
Was 20.
27. Somebody will ask me during homework, so I'll probably do it later. But let's do one that looks easy, but is just sometimes a little weird. This one here. Because there's no variable. That's the only reason it's kind of weird. And it's a free homework problem, so that's good. What was that? Yeah. Lauren was just doing some little dance, which I think worked out to be a 9. Is that what it was?
Yes.
She's like, now it is. Yes. That's exactly what I meant. So what can I divide out of both those terms? 9. So again, sometimes there'll be weird numbers which aren't as easy to figure out what to divide out. Then you can do the prime factorization if you need to, right? So I can't take any letters out because the 27 doesn't have one. So I just take that 9 and that's what goes in front of the parenthesis. 45 divided by 9 is 5. There's no other b to subtract from, so you just bring that b down, just write it down. 27 divided by 9 is 3. Okay? All right. Next thing we're going to do is that story problem you got a brief glimpse of.
Why don't you add the b to the 9s that are divided?
Because 27 doesn't have a b, so you can't divide a b out.
Oh.
Okay? That's why I wanted to do this one, because of that question, anticipating. All right. Fun story problem. Draw a circle and a square on your paper.
What number is it?
This is problem 4. It's not a homework problem. So example 4. So we're trying to find the area of the shaded part. I highlighted. So let's read it. A helicopter landing pad, or helipad, is sometimes marked with a circle inside a square so that it is visible from the air. That rhymes. What is the area of the shaded region of the helipad at right? write your answer in factored form. So we go through this whole big process to factor it, basically, which is kind of annoying. When I did this problem last period, I forgot to read the factored form part, and I'm like, why did I have this problem? It doesn't even make sense. So if you want the shaded part, we have to take the square and subtract the circle. How do you get the area of a square?
You mean circle?
No, I mean the square.
Oh, based on height.
Based on height, length times width, whatever, however you want to say it. So we do base times height, because it's good to have the formula down too. How do we do the area of a circle?
Pi times radius squared. Wait.
Yep,
Is
you're right.
that in the wrong order or what?
Doesn't matter. Pi r squared. That's how I write it. All of you guys, I think you get schooled on it in middle school to write 3.14 instead of pi. Don't do that. Pi is accurate, right? Because if you write 3.14, you're rounding, which means you're leaving off an infinite number of digits, which is not accurate, okay? So just leave the pi, it's fine. You don't have to write the 3.14, and it makes it easier as a result. Okay, so we know that the length here is 2x, or the base is 2x. What's the height? 2x, because it's a square, the sides are the same, okay? So we're going to get the area of the square, we do 2x times 2x. Then we're going to subtract pi. The radius right here is x, right? Radius is halfway across the circle. Diameter is all the way across the circle, just to remind you. So it's x squared. Okay, so now we multiply this stuff and then factor it. So 2x times 2x, 4x. 4x what?
Squared?
Yeah. Remember, you write the little ones, you multiply the numbers and add the exponents. You see why it's a good idea to write the little ones now?
Yep.
Proving it to you, right? You still won't do it, but I'll continually try to prove it to you. Because you like getting math problems wrong. I know you want a lower grade in this class. That's why you don't write the ones. It's like an evil plot high school kids have had for the last 19 years I've taught in high school. Can you believe I taught elementary school my first year of teaching?
I don't think that's the square at all.
Isn't that hard to believe? And I was not a whole lot different as far as how I taught. But I taught elementary kids with, with emotional disabilities. Halo's heard this story, many of those stories anyway. My first year teaching the kids with emotional disabilities. There are lots of good stories with that. And all of those kids would be like, God, they'd be like in their 30s now, which is crazy. I was 29 my first year of teaching. I'm 52 now. Insane. So we got to factor this. What can I divide out of both these terms? How many? What? Hold on. Ari just had a funny comment. Ari said, how many parents emailed you saying their kid came home and said something inappropriate? Said I said something inappropriate? Is that what you mean, Ari? I say inappropriate things all the time.
Yeah, you taught them something and they repeated it.
Yeah. You know, that was funny. Like when my kids were toddlers, we tried not to swear around them, right? Because then they'll go to preschool or whatever and swear at their teacher. So my ex-wife and I would say freaking instead of the other word. So he'd be like, you stub your toe and you're like, ah, that freaking hurt. And then of course, we like pick the kid up at, one of my kids up at preschool, and they stub their toe and they're like, ah, that freaking hurt. And I'm like, oh God, you can't say anything around these kids. Just repeat everything you say, you know? Like, God, that sucks.
Would you divide 5?
What can we factor out? What is in common between these two terms?
X to the second power.
X to the second power. Yeah. X squared. So we take that, write it in front of the parentheses. What do I have left in the first fraction? 4. Second fraction? 5. Right? I talked to you guys about Pi Day already, right?
Yeah.
And what was the number of pies?
69.
69, of course. What else would it be in a high school classroom, right? All-time record, 69 pies. I'm like, oh my God, of course. No, that was the first day we were in quarantine, was pie day.
That was so sad.
I had a picture of a Miss Bennett, who works at the school. I had her son last year, and early in the evening, she sent a picture of making the pie, all happy, like, yay, pie day, I can't wait. And then school got canceled, quarantine, and then she sent another picture of him like, oh, no pie. I was like, at least you get to eat it. That's not all bad, but we may never see it again. That's not cool. Okay, so that's it. Any questions? You guys good? Homework is right there. Page 495, 9 through 39 on. Page 495, same problem numbers as yesterday. It's like deja vu all over again. So page, nothing. Got nothing. Page 495. You're writing this on top of your homework with the problem number so I don't take points off.
Yeah, done that to me before. Thanks, Quincy. Quincy and I used to always forget that, and
Yeah.
he would yell at us for it.
Nah, just take points off.
Yeah, we got like...
I already told these guys they take points off and write, ha-ha, just to rub it in.
Yeah, I think I still have one of those.
I'm that guy.
Like,
It's true. I'm that guy. Okay, we're going to go take a math break. You guys are going to start working on your homework, and we're going to get the hell out of this 77.9 degree classroom, because it makes me want to hurt people. And I like these guys, I don't want to hurt them.
I'm not in that and
You're not?
no.
And you got a hoodie on too.
Yeah,
Yeah. I'm like right on the edge of sweating profusely. All right, let's go take a math break. We'll be back in 5-ish minutes. Turn off my mic so you guys can hear a riveting conversation.
I remember you talking about absolutely crazy.
Oh, yeah. Awkward.
problem.
78. It went up a tenth of a degree since we left.
Oh,
Woohoo.
thanks. Thanks.
You go hang out in Mr. Grace's room. It's cooler in there.
How dare me.
Feels about the same today. Yours is normally cooler. Huh. Weird. Just enough to kind of make you a little weird.
I think I forgot how to do this. So did I. Like, I got it. Like, I know, but I like still having this solution to know. We learned how to do it the first time.
I kind of forgot.
Like,
7x squared plus 28x.
oh, I forgot to keep that. I mean, no, did you just say the answer, or is that how you do it?
I said the answer.
Oh.
7x times x is 7x squared. 7x times 4, 28x.
Thank you,
Oh.
7.
Free, you get two free problems today.
Yeah.
17 was the first one.
Wait,
Yeah.
7x squared plus what? I mean,
28.
24x?
28.
28.
7 times 4, 28.
Is that right? Wait, is there an x? I'm maybe
For 30m squared, or yeah, 30m squared plus 3m cubed, except you got to write 3m cubed first, right? Because the highest exponent goes first. So just go like that.
I do?
Yeah. Standard form, always highest exponent, then next highest, and so on.
Oh, okay.
Any questions at home? I bet you they're all playing video games and nobody's there.
Oh, I bet they've already finished their homework.
We were joking around, like, if I were in this environment, I'd be like, turn the camera on, go play video games for 45 minutes, then come back. I'd like to figure it out on my own, so.
I mean, like, in, like, every other class of mine, I'm usually on my phone.
Yeah. It's too entertaining, right? I try to make it entertaining so you guys want to pay
It's so
attention.
distracting in my home, like when I'm in my house, because I need to be in a school environment.
Yeah.
Or else I get distracted and I miss one thing, and then the rest of the class I'm like,
Yeah.
oh, yeah, I do so much better in person.
Yeah, I know.
Like, and I'm not good at like online tests or anything like that.
Right.
So that's great.
Yeah, no, that's tough.
Yeah.
Okay, I'm sorry.
I swear to God they're all gone because nobody even said
How
anything.
do you do number 11?
Is anybody up there? Nothing. I'll show them all to you.
The thing that implanted in my brain is how to do it the opposite
Oh,
direction.
but then you guys won't be able to see this, so that's not a good idea. Never mind. Which one are you asking about, Charlotte?
11.
So 3 times 10 is 30, so 30m squared,
Oh, plus.
and then plus 3m to the third power.
Okay, thank you.
And then you got to write 3m to the third power first to make it in standard form. So it's 3m cubed plus 30m squared. This isn't even the hottest classroom. The one that we passed going up the stairs over there on the corner is the hottest because it's got windows on 2 sides. And for some reason, Mr. Grace's classroom gets more air. I don't know why, but it does. You guys are done with your homework. You can peace out at home.
Pretty sure I
I know. I keep talking to him. Nobody says anything.
27.
Hey! What's up, Sasha? 27? I was waiting for that one. So you guys should pay attention to 27 as well, because,
I'm just going to do it right next to it.
yeah, I don't care if your homework's out of order. I just look for the problems, and it's easier if it's in order, but whatever. Okay, 27. So we have a circular mirror surrounded by a square metal frame. And they almost always want you to get the corners. So again, we're doing square minus circle. So a lot of students think that's stupid to put that up there, but it seriously helps you guys just to figure it out. So the radius of the mirror is 5x. And the length of the metal frame is 15x. The height is also 15x, so we multiply those two. And then we have pi r squared, so this is the only one that's a little funky, because you have to square the whole thing, the 5x, which means you got to square both parts of that, so that's where students sometimes will make mistakes. So you get 225x squared minus pi 25x squared. So what can you factor out? 25x squared. So, you know what I realized? I forgot to turn off the recording.
This is the second time.
I know. And try to remind me, like, especially if it gets hot, I'm like increasingly brain dead as time goes on. So when you divide 225 by 25, think how many quarters are in $2.25? 9. Good. So 25x squared. Right, so how did you do it so fast? What do you think?
I suppose there's 4 quarters in $1.
Exactly,
And then 25
yeah.
cents.
4 quarters in $1, $2, 8 quarters, 1 left, 9. So 9 minus pi, that is it. Just wait, are you guys done writing that? And I'll go back to the homework. Good?
No. Wait, I think I got it.
That was like Halloween note. I had a student teacher. It was so funny. It's funny in a mean way funny. She was like writing on the whiteboard, and she was so nervous. The first day I had her teach, she literally wrote like scary writing, like the wiggly kind of writing. Like, calm down, girl. It's gonna be okay.
Oh, that's my writing.
She was freaked out.
There.
Yes, your handwriting is not all that beautiful. No.
It's awful.
Mine can be.
If you take your time.
I
and
like
like,
the class. You know, if I'm taking
your homework is always like, I wrote a little comment, I don't know if you ever saw it, but, yeah. I wrote a comment, like, I always look forward to grading your homework, because it's like, pretty.
I like to make it like really organized.
Yeah, no, that's a really good habit, too. And then Austin is like,
It's like, just like, awful, I don't know why.
it's just, like, not everybody writes me. My writing has gotten better over time. When I was your age, it was messy, way messier.
Well, like, I also, like, didn't really learn how to fully write until third grade or something.
Do you guys know how to grip a pencil properly?
Yeah.
Do you know the exact way? That's not it. Let's see. Like, put it to the paper. Then you can tell. That's perfect. See, people have weird pencil grips, too.
I
Like,
see someone whose pencil grip is like this.
Yeah, some
You
people-
hold your pencil the same way you hold your silver.
they hold it like a claw. I'm like,
Yeah, you said.
you're supposed to put the top against that first knuckle of your hand. So I always write with my pen down there, like in between. You're supposed to hold it more upright, and then you have better control. Like, that's perfect.
Oh, I hold it.
No, you're
definitely
supposed to have
upright.
it.
Like super unupright.
Oh, that's That's it? Bye, everybody who's pretending to still be here. No, nobody said anything. They all just left. That's so weird. Rude.
Ow.
So weird.
We will say bye.
Yes, you guys will say
Thank
bye.
you.
All right. See you, Shay.
See ya.
Christian, Santiago, peace out.
Wait, can I try writing on this page? It looks
Yeah.
so cool.
Sure.
Yeah. Me too.
Now, you guys might pass COVID to one another, just saying.
I don't think it transfers that.
It does sometimes, but you'd have to be like, achoo! And then,
Yeah,
right?
but don't totally lick the pen.
Here's the cool thing.
Oh, he's beautiful.
Oh, nice.
Oh my God. It's so beautiful.
Here, I want to show you a nice trick. Oh, that one's dead. Hit this thing right here. And then go down. Wait, right, click that one. Freehand shape. And now make a shape. Oh, that was a cross with the line.
I don't think they can do that. Bro, wait.
Now the whole class is going to have COVID, so nobody wrote on the board, okay, in case that happens. I don't know if it'll do hard. Oh,
That's not cute. Mine was better.
make a star. That's a good one.
I'm just gonna like make it like this.
Okay. I'm super curious if it'll do it.
Oh.
I know. It's such a crowd pleaser. That's why I like it. I normally won't tell you guys, and I'll be like, look how good I can draw a circle, and it's all wiggly, and then it goes snaps perfect. And you're like, what?
Why didn't mine be perfect?
It doesn't like it.
Well, look at mine. Mine looks weird. Like that's not hard. Look.
I don't think you can pick up. Oh,
It's
maybe
still
because
weird.
you picked the pen up. I thought you couldn't pick the pen up, but that just.
Yeah,
totally
wait,
just
I'm
did
gonna-
that. Never tried that.
Oh, the screen looks beautiful.
Oh, it does.
You can make one. All
I
right.
have one. It's so good.
Oh yeah.
Let's try it.
Softball. That's why you can't write me.
What?
Left-handed.
Yeah, I didn't went till third grade.
That's what gets people.
There you go.
Perfect.
We also standing in.
I know. All right. We'll see y'all later. I have to get home.
Hopefully
Yeah, I know. I hope so.
Thank you, Mr. Rogers.
Hopefully this isn't by for the rest of the year. you know?
Hopefully not.
I hope not. At least one more time would be nice. Makes me sad even thinking that. I look forward to this class.
Well, it's bad for all the grades. It's bad that it's our first year in this school.
I know, and
we have to,
this
like,
is the first year you have. That's crappy.
Except at least this isn't like our last year to do things.
Yeah. At least you got some more chances of stuff
Yeah.
getting normal.
I know a lot of people who like it's their last year here, so for
Yeah.
marching band they were sad that there was no.
What did you get to?
Oh, I don't know.
78.4 for me. 78. Yeah.
I heard you saying about Fairview, there's nothing on the COVID dashboard.
Okay.
Can we see?
No, it's just some former students. See, Charlotte? Some former students told me that, and I was going to check, so curious.
The dashboard and it's on the BDS either, so like.
So you know what it's going to be is because of Halloween.
Yeah.
That's what's going to shut us down.
Sure, if anybody wants to go party or hang out with their friends, which I'm
And
sure
who
they
didn't,
did.
you know?
Yeah.
And it's all the chowderhead, like, popular kids.
Jackson has to come here with my whole Halloween.
I know.
So.
It's so sad, right? You're like, that's my Halloween?
In the instant I was debating on dressing up, and I was like, that's Halloween.
Yeah.
I love dressing up.
That's all you get.
Yeah,
I know. It's so sad.
it is, yeah. But I'm sure that not everyone was that responsible. So,
Yeah. No way.
Yeah, so yeah, I think we're gonna get some positive.
Because, did I tell you about that kid yesterday? I know. I know. I didn't eat lunch with them today, just because I'm like, I'm honestly hoping we get shut down, only because I want to go see my parents, and I'll just drive out there, because my mom is like mid to late stage dementia, and not a whole lot of time left kind of thing, so I'm kind of hoping to get shut down, so I can stay out there for a couple of weeks and just help them. Yeah. And it's fine. My dad's got an office in the basement thing that's it'll work. I know. I know. I totally agree. And you see, like, just talking to people, their stress levels, you're like, I know. I went down, let me make sure I'm off all these things somewhere.
My meeting is on.
Okay.
Oh, that's you.
Okay. Yeah, it's all good.